Hi, Dean Kershaw here, Kershaw Instrumentation. We're here today to talk about our falling rod viscometer model FRV2000. When you purchase this instrument from us, you will receive a number of different components. We're going to talk about each one of those components here today and actually assemble a viscometer and run a test. Right after this presentation, we will have another presentation on the SAV09, which is our semi-automatic viscometer interface. The purpose of the semi-automatic viscometer interface is that it will take the data that we will acquire from this test and automatically put it in a computer, calculate the viscosity and the yield values for the substance that you're measuring. We'll discuss that. We'll discuss that feature later on. But for starters, the viscometer consists of a base, which has a weighted bottom, and we have adjustable feet, and there's a bubble level on the back here that will allow us to level the instrument. We have a top plate, which is intended to support the rod and collar, and we also have a trigger mechanism that is used to actually start the test. There are two photocells. The upper one is the start, and the lower one is the stop. You'll notice that these photocells are mounted to a horseshoe type bracket. These particular brackets are designed for our frame here, but we also make a longer version of this, which will fit on the older Leray viscometer frames that are out there. You'll also notice that this bracket has a screw with a point in it. That point fits into an upper groove for the upper one and a lower groove for the lower one. These two grooves are exactly 100 millimeters apart, and the ASTM 4040 specification specifies that our fall time has to be measured over a distance of 100 millimeters, and that's where this 100 millimeters is established from the position of those grooves. The second part of this device is the actual rod and collar. This is the real nitty-gritty to the test. The rod looks like this. It has a precision ground surface on the outside, and it weighs 130 grams. The 130 grams is factored in to the formula that's used to calculate the viscosity and the yield value. Now that rod fits into the collar, which we're going to demonstrate in a moment. The collar has a hole in the side where you can put either a thermometer or a temperature probe that lets us measure the collar temperature during the test. You'll notice that there is an area machined out of the top of this collar, a well, that essentially accommodates the ink when we're actually running a test. If you look inside of the collar itself, there is a finely machined and honed surface in there that's actually tapered. And as the rod passes through that surface, we're shearing the ink, and that is what's actually generating the data that we need to operate this test. So the collar fits like so, and the rod fits in like so. That's ready to operate. The next device we're going to talk about is this is a temperature collar. This is our part number WC-101, and essentially this is a hollow vessel. It has a fitting on both sides, and it fits over the test collar as such. Normally we have hoses connected to both of these, and we have it connected to a water bath where we can control the temperature of this vessel and attempt to keeping the collar temperature at a steady 25 degrees centigrade. We're going to not use this collar for our demonstration, just to kind of simplify our demonstration. So I will set that aside. We also have a series of weights. You can see we manufacture small ones as small as 25 grams, 50 grams, 200, and so forth. We manufacture these weights all the way up to 5 kilograms. The heavier weights, 1 kilogram, 2 kilogram, 5 kilogram, and so forth, they're going to be used for heavy coatings and overprint varnish, things like that that are higher in viscosity. For our demonstration here, I think we're going to be using 1 kilogram and 2 kilograms. Now you'll notice each of the weights have a hole in the bottom and a pin in the top. and that's so that the weights can actually nest on top of one another. So for example, right now I have 100 grams. I can add 200 to that. I can add 50 to that for a total of 1250. Now I've got 1275 and so forth. You get the idea. So we have just a couple of weights, and we can make a whole gambit of different weights from that. So without further ado, I'm going to go ahead and we'll run a test, and we'll demonstrate the principles that we've seen here. So I'm going to coat the rod. So what I have here is some overprint varnish, and generally we have a measured amount either by volume or by weight. I'm not going to do that, but this is a reasonable amount of material that I have here, so I'm going to put that on. And we'll set that aside. Now the first thing we're going to do is we want to just simply coat the rod. So I'm going to just put some weight on there to give that a hand. We're not actually measuring anything here. We're simply coating the rod so that when we run our test, we know that we've got valid data. So that'll work. We may even want to coat it more than once, but for our demonstration purpose here, we're not going to coat that again. Okay, so this is going to be our first drop. So I've got a 1 kilogram weight on the rod, and our elapsed timer is reading 0, and we're going to go ahead and do the first drop. So our elapsed timer is timing because we passed the rod has passed the upper sensor, and when it crosses that lower sensor, our elapsed time will stop, as it has done there. And you see we had an elapsed time of 10.88 seconds with 1,000 grams of weight. So normally we would record that number. We would pull the rod back up, and just to ensure that I've got a good test, I'm going to put some ink back down in this well. Our rod is well coated, but we're just going to make sure we have a good supply of ink. Now what I'm going to do, this time I'm going to put on 1,500 grams. I have a 1,000, a 300, and a 200. So I would expect to get a shorter fall time because we have more weight. Now here we go. So this time we got a fall time of 8.66. The last time with 1 kilogram we had 10.88, so we got a shorter fall time this time as expected. Now at this point, after we follow this drop procedure several more times, we'll have enough data that we'll be able to calculate the viscosity and the yield value. The information that we need to do that is we need the fall times, which we have recorded from our display. We need the amount of weight that was applied to the rod, which obviously we can physically see right here. And we also need the temperature data, which we would have measured using a thermometer in the collar here. We take all of that information and put it into the formula, and that will generate the viscosity and the yield values for us. This concludes our presentation on the falling rod viscometer, but I would encourage you to look at our other presentation on the SAV, the semi-automatic version, where we're actually going to do these drops, and we're going to have the computer tally up the data and calculate the yield and viscosity.